All right, welcome everyone. Super excited for this talk that I get to do again. I'm Rehgan Bleile. I'm co-founder and CEO of AlignAI. And a couple of weeks ago, I was in Boston with my team, and we had the opportunity to keynote the Open Data Science Conference, which was amazing. And the topic that I picked was kind of interesting because it's something that we have been talking about for quite some time now. It's a sort of new way of thinking in the enterprise, and I think it resonated with a ton of people that were there. Definitely a lot of our customers think about this from a life cycle perspective. So how do I go from idea to refinement, to risk eval, to feasibility assessment, to development, to testing, to approvals, right? And then eventually to production and monitoring and, thinking about it from a sequential perspective. And I think that's the right way to think about it when you're tying it to business objectives and you're trying to understand, okay, how do we create an AI portfolio at our enterprise? What is the value of that? How do we place the right bets? How do we get things through quickly, especially if we're dealing with regulated enterprises? So obviously we have a lot of experience with that, and we talk about the AI lifecycle quite a bit at AlignAI, and there's several blog posts actually on our website. We spend a lot of time thinking about content and not using AI to create that content and actually writing it ourselves and being really thoughtful about what we're seeing. So you should definitely head over there and check out some of the articles and blogs that we've posted somewhat recently. But what I'm going to be talking about today in this talk is more of a blueprint approach. So thinking about AI from a holistic lens. And you can still think about it from a life cycle perspective, right? How do we get this AI system through the process faster and adding value? But when we really think about the success of an AI system, we have to think about it from a design lens and from a holistic view. And so that is why we kind of coined that term blueprint. And what we mean by it, I will explain in a little bit. And I promise that you'll start to understand why I put elephant in the title as well. So let's start with that first. There's a parable that some people are familiar with, where there were several blind men that came across an elephant, and each of them was touching a different part of the elephant. And each of them, because they could not see the entire elephant, thought that they were touching something different. So they, one person touched the side of the elephant, thought they were touching a wall. One person was touching the trunk and thought they were touching a snake. And one person was touching a leg and thought they were touching a tree trunk, right? And so because they can only see part of it, they really didn't see the whole elephant to understand exactly what it was. And because AI has become so cross-functional inside of an enterprise, because it involves the business stakeholders and has so much operational disruption, and not just automation, right? Like full process operational disruption in a lot of cases, at least for the larger scoped AI systems, right? And because there's a lot of kind of new territory around risk and risk profiling for these types of systems, these non-deterministic probabilistic systems. Your risk teams and governance teams are looking at it from a very particular lens. And then you have your technical teams where the entire technical ecosystem is kind of shifting underneath them. And so they're trying out different models, trying out different architecture, they're trying out different structures, architectural structures for data. And then again, you've got your whole data team who's trying to now procure a new data source, which is highly unstructured and needs to scale. And so you've got your data teams who are trying to prep data for AI. And then you've got your leadership that is thinking about how AI can be implemented from a strategic lens. So of course they're reading all the books and they're going to all the talks and they're hearing kind of the art of the possible and the cutting edge. And so they're looking at it from a level of sophistication and how AI can disrupt different things inside of their own organization so they can stay competitive in the market. And so all of these things are super important, but each of these teams tends to look at it from a very particular lens. And we did a study through GLG back in December where we actually surveyed at a bunch of different AI leaders inside of financial services enterprises. And so we posted the results of that on our website as well. Some interesting findings, one of which being the number one problem was this coordination challenge between these different people. It's like a translation issue, right? The specs and the things that risk is considering and trying to communicate that to the technical teams or the data teams or the business teams is really breaking down. And it's causing a lot of issues. And it's causing everybody to move much, much slower than what they want. The second, I think the number two thing was data readiness, which was also a blocker and a huge slowdown. So that's what I mean by the elephant, right? This AI elephant that is just like no one can really see the whole thing. And so what happens is that they're only seeing parts and all of these gaps are showing up. And they're showing up when it's like way too late in the process. And so like lots of time has been spent working with the business, trying to get some specs from the business and what this AI system is supposed to do. Lots of time has been spent by the technical teams doing technical feasibility assessments, proof of concepts, pilots, things like that. And by the time we actually get it to this like go live or get it towards production or even get it in front of the risk team, we either have missing information, which happens a ton, right? We don't have all the context for what we need for us to properly assess it. Or we have made a huge assumption and we actually have to go back and fix it. And so this is extremely costly and it's slowing everyone down. And if we look at the crux as to why adoption is not happening more rapidly, this is definitely a big piece of it. There's a whole kind of literacy and adoption side to that too, like coming up with the ideas and getting people to actually leverage it and figuring out how to seamlessly integrate that into existing operations. That's kind of, it's related, but a little separate. But this core piece is really why things are falling down. And so again, in isolation, it seems pretty functional, actually. The technical teams are like, it's working. The data team said, this is the data you asked for, and we got it ready for you, and here it is. The business said, this is what we wanted. This is what we expect to happen. So from their view, it's fine, right? But as it goes, we end up trying to rush towards business outcome. We see that there's issues. Maybe the data set that was procured for that use case, there were a lot of assumptions on the context of those fields, or maybe we just don't know where that field came from or what it means, or if it's truly ready from a quality perspective. Maybe we had some unclear goals and we optimized towards the wrong thing in the solution, which happens a lot, right? Because there's a breakdown in user experience and expectations and automation and what actually gets built. Maybe there's been zero trust established by the solution that has been proposed, or we got all the way down the line and then, the business teams are unwilling to adopt it for several reasons, or it's just wrong in the wrong ways, right? We know that there's going to be errors, but those errors are just too great compared to what they're currently doing. So there's no incentive to actually adopt it. And of course, with the risk team, we just discover those risks too late. And again, these are months of back and forth. When we did a couple of studies across our different customers, we saw that, this is like a 9 to 12 month plus process, right? And we've got built solutions versus bought solutions versus kind of what we're calling this DIY, which is, build your own agent kind of thing. So it's not fully developed, but sort of, right? And all of these systems take forever. Now, they all have different kind of lead times on how we assess them, but they're still way too long. And talk to any executive, any leader, they will tell you this is taking way too long. And we want to be cautious, which is fair. But there's a more methodical way of actually evaluating risk and all the different dimensions of risk. And so that's what I'm going to talk about today. We're going to go through a little bit of a use case here. And this is a highly simplistic use case, right? We're talking about an auto credit risk example. And so this is we're calculating the probability that someone is going to default on something like a loan. And we're going to use that to understand whether or not we want to issue them credit and how risky they are. So we have an applicant that comes in, that applicant comes with data, right? And that data is used into our system. This is more of a what people would call trad ML or traditional machine learning type of use case. But again, if you were to leverage something like Gen AI or agentic systems, this only gets more complex. So the reason I'm using a more simplistic use case is because it's easier to understand. And so we're looking at this probability of default, and then we have these kind of risk classes that we attribute to that. So if they're high risk, we're going to auto deny them. So anything above a 0.6, auto deny. Medium risk, we might have a human in the loop where we do a manual review. And then low risk, we'll auto approve them. So we'll follow that use case throughout this talk, but I talked about the blueprint concept. And the reason that I mentioned it up front is because when we think about blueprints, think about a blueprint for a home. What is a blueprint used for, right? So we actually generate all the specs and details about the home, and we derive those specs and details from the intention of the home. Is this a single family home? Is this a condo? Is this a commercial building? And what is its function? Right? Single family home, maybe it's 2 bedrooms, 2 bathrooms, and there's a particular market for that. And, that's what we're designing. And then there's some best practices out there on how to structure a 2-bedroom, 2-bathroom home. And when you go to get permits and go to the permit office, they're going to want to see all the details about what you're building. Or if you're making modifications to that building, they want to understand what those modifications are and the implications of that. And they have tons of codes that they will reference, right, to issue a permit. It's pretty similar in that sense. But the nice thing about a blueprint is that it's one singular document or source of information that people who are building the home, so the construction teams can, people at the permit office can reference, people in real estate can reference. And if you're adding real estate to a portfolio, if you're purchasing something, you want to look at the blueprint. And similarly, if you're buying it as an individual, you want to look at, a quasi blueprint of that, right? A version of that. And I think this is a really nice parallel to what we're talking about with these AI systems. Because when we think about it holistically, we're saying, what does this do from an operational perspective? And there's a ton of things that it can touch from a business impact or operations impact lens. From a risk side, again, we need a holistic view of that. And as we start to tie in data sets, we can start to compile all of these things in one place. And so you might be thinking, hey, that sounds like a PRD, or hey, that sounds like a waterfall methodology. But that's not exactly what I'm talking about. I'm more so referencing a highly connected system. So a system that is dynamic, highly connected, iterative, and as it goes through the process, it matures and it becomes more complete. And people can leverage the information there more dynamically. And what I mean by an interconnected system is think about your blueprint being actually connected live to your data catalog. So as data shifts and changes and becomes high quality, low quality, this is why we have like observability on things like this, because it's not a set it and forget it kind of thing. Or, an AI system that's been approved, there might be several use cases for it over time. Maybe some team in another department picks up on this AI system and wants to leverage it for different reasons. Well, it might be applicable for them. And if we want to reuse the technology that we have, we may want to consider adding that use case to the blueprint for that system. And same thing with risk. The regulatory environment is evolving, right? And we want to be able to keep up with that. So I'm talking about a highly connected dynamic system that can pull in all the context around these AI systems and can always keep everyone aligned on what it is, what it does, and some of the risks. So we're going to talk about how to create that cohesive AI blueprint. I should have mentioned this too at the top. We are doing this live, so if you have questions, feel free to throw them in the chat if you're with me on Zoom. And if you're with me on LinkedIn, you can throw comments in there too, and the team will push them over to me on the Zoom meeting. So please ask questions throughout. I'm happy to answer them. So let's talk about this blueprint. I mentioned some of the different components here that we need: decisions, context, reasoning, boundaries, right? At the decision level, I think people oversimplify what we mean about decisions and decision support. If you think about all the individual decisions that somebody like in a call center makes, it's a lot of decisions. And if we think about agentic systems, there's lots and lots of decisions that those agentic systems can support. And those decisions end up having consequences. So if I actually act on something, like I issue the credit, or I issue the loan to the person, they will have some sort of activity and there will be some sort of consequence to that. So they'll either pay their loan on time or they will default at some point, and we'll start to see the consequences of that. So that's what's usually considered a first order impact on that system. So a decision was made and there was an outcome that happened. And some of the more sophisticated companies that we've talked to or that we're working with, they're using things like process mining tools to be able to understand the complexity of those decisions and different processes that they have in their organization, which is really smart. And so they're identifying obviously areas of opportunity where those decisions are really rules-based and, deterministic in a way, and maybe don't really need AI at all, and can just use regular code and automation. Or if it would benefit from something more probabilistic, and if so, what's the level of complexity around that decision? So this actually takes a lot more than just what decision's being made. Write the decision below. We're talking in complex environments, especially like healthcare or financial services. We have lots of implications of that. Down below, we have context. So again, what data is valid? What does it mean? Is it applicable for how we're using it? And as if anybody here is in, in like data stewardship or curating data, you'll know how hard this is. If you ask, I remember we did one exercise with a customer of ours years ago, and we went to their customer support team. And we asked every single person who does logging of reason codes for folks that are contacting them, what these different definitions of the dropdown items were that they were logging the reason codes for. And every single one of them answered completely different on several of the codes that they were using. So when you're looking at the data, you're actually making decisions on poor quality data because those categories are not accurate for what's actually happening. And that's just like a BI and data quality example. But when you're using AI, again, it's going to pull from the context that it has. And if it doesn't have additional context on what each of those things mean, then it's not going to be able to behave accurately. And so it's actually so much harder than you think, and it requires a ton of context. And then reasoning, how does the model produce an output? In some cases, the reason it gave that output is way more interesting than the output itself. We actually worked with a automotive company that they were actually a lot more interested as to why vehicles were being delayed than which ones were being delayed. So that they could start to do some root cause analysis on those delays and they could address them. And the reasons were not obvious, obviously, because we used a probabilistic solution there. So the reason behind those delays were not obvious, and they learned a lot in that process. And so sometimes the reasoning behind it is super important. And then what is the system allowed to do? We talked about boundaries, and actually yesterday I just did a talk on how you can automate guardrails based off of your governance structure. Maybe we'll do another webinar of that talk, but those boundaries are really important. If you actually can be systematic about how you do them. Cannot tell you how many people we've worked with that just have completely arbitrary reasons behind why they consider something high risk or low risk. And there's so much inconsistency across risk evaluations that they end up having a lot of risk exposure because of that. And so I'd say like the boundaries need to be pretty well defined. So going back to our example here, everything that I do when I'm talking about AI always starts with value, because everybody is always aligned with incentives. And so if we talk about aligning objectives with the value itself for this example, we're going to look at the money behind it, right? So because if we're issuing loans, that's exactly why we're issuing loans. We want to make money. And so there's a loss reduction that we want to optimize for lowering the loss reduction. And then there's a cost savings piece. So if we look at number of applications we have, average loan, approval rates, default rates, we can get this off of historical data, obviously. And then we look at the revenue lift. So additional loans that were issued, our portfolio that has increased, and hopefully we're getting higher quality folks that we're issuing loans to. And then this default rate, we want to decrease the default rate, obviously. And so if we're doing a better job at selecting applicants, then we will do that. And we can look at the savings associated with that because of the defaults. And then we can actually, quantify this. And something that I had said that seemed to resonate with a lot of people during the keynote was that, yes, the number 10 million on the slide is interesting, right, to most executives and leaders. But the way we calculated it is actually way more interesting because we can make adjustments based off of historical data or performance as we go. But if we're all in alignment on how it's calculated, that is what's important. And you can iterate on this type of stuff over time. But knowing how you're attributing value, it might be as simple as what we're talking about here, but it might be, less simple. And I think there's a distinction here between things that are like process oriented. We're talking about throughput, we're talking about value. So if you're talking about calls and call centers and number of people that you have to employ to service a call center and the number of customers that you have and percentage of people who call in, like these are all very quantifiable things. And we can also probably quantify the cost of a call to an extent. And so if we can lower the number of calls because of something that we did to support customers outside of having them call, or if we can shorten call times, we can actually quantify that pretty easily, as long as we can attribute it back to the system that made those adjustments. And then there's some squishy things like productivity tools where, okay, maybe we save some time in somebody's day and now they're reallocating their time. And I heard a really good quote from one of our customers that said, like, how do you quantify the ROI of an email? Like giving somebody access to email. Like when everybody got email, how do you quantify the ROI of that? I don't think anybody does. Everybody pays for email and then nobody really quantifies ROI on it. So I think some of the productivity stuff like doesn't really need to follow the structure per se. There's probably a justification for growing top line revenue and not having to hire more people as you grow. Or of course, there's the conversation that people have, headcount reduction because of productivity gains, but I see way less of that, to be honest with you, than I do on ambitions of growth and not having to expenses alongside that growth. So very interesting conversation to have around ROI, but I always start here. And then we get into the decisions themselves, right? And again, the very simplistic example I'm giving you here, right? The decision type is we approve, we deny, we review. So it's pretty straightforward. We have success criteria, and we have some trade-offs associated with the errors in our system. So precision versus recall, which I don't know if any of you have dealt with trying to explain that to somebody who's not, in the kind of stats and math field, or not in your technical field. Some business stakeholders on the implications of precision versus recall, but very real, right? And then the value, which we just talked about. So when we're talking about the business need, we have to speak in the language of the business. So the implications of error. So these probabilistic systems are going to be wrong. How wrong are they? What kind of error are we talking about? And what are the implications of those errors? That's what it boils down to. And whether or not you can trace it back to a consistency of errors, as I think one of the top concerns from risk teams. So I see a question came in. I'm just going to read it real quick and answer as we go. So you briefly mentioned agents and more adaptive interfaces as a new frontier. How do you apply the same approach to agentic systems where the decision space is much more open-ended and the boundaries zone is much harder to define? Great question. I actually just, like I said, did a talk on this yesterday, so it's fresh in my mind. So this is going to sound counterintuitive, But boundaries on agentic systems have to be more so like rules around them do have to be deterministic to an extent, right? We need to create a set of rules around agents. Now, how you implement them to ensure that those boundaries actually do prevent them from moving outside of the decision space is a little bit harder of a technical question. That might be where you're headed, is how do you actually do that? Now, defining what you have to do up front in terms of boundaries and getting to the guardrails around agents um, can be somewhat non-trivial. And so I talked a lot in that talk about universal principles versus context-specific principles. And with agents, you have to define exactly what they do and what environment they're in, what access they have, what tools they have access to, what their objectives are. They don't always stick to the objectives, but again, I think that's how you design it and implement it. And then how they're orchestrated. So a lot of people are going towards the sub-agent type of structure where you have a lead agent who's orchestrating the overall objectives, and you have sub-agents who are assigned, more specific tasks. And I think that's the right way to do it, because then you can start to make sure that there's some organization around that. And when we talk about like deterministic versus probabilistic, I think people think it's like one or the other in a system when you can actually have both in one system. So we can be very deterministic about what it should and shouldn't do. But the way that it does it can leverage probability. And so those agents are great because they can actually leverage probability to come up with examples, and they can kind of pass that off to other agents or to the lead agent, and there could be some sort of outcome, which could have a human in the loop, right? But at the end of the day, we still set an objective and we still set some rules around that. And there are several ways to implement it. Maybe we can do a whole separate talk on that. So hopefully that's helpful in that question. It does become a lot more complex, right? Because the structure is more complex, and because we're trying to delegate a little bit more autonomy than a simplistic ML system like what I'm talking about here. But the principles still remain. We still want to look at the overarching business operation that they're working within. There were some good examples at the event I was at yesterday. Actually, I'm going to do a quick shout out here to Sean Erickson, who runs Cloud Nirvana. That's the event that I was at. He was talking about how he built 11 or 13 different agents to help run his community. And one of the agents was to source speakers and to evaluate presentations and to, surface speaker information for things like the website and emails and whatnot. And he named that agent Mike, like microphone, which I thought was cute. But that agent had a very specific task and objectives. It was to focus on speakers, finding speakers, reaching out to speakers, right? But each of those things that it was told to do or was designed to do is this decision piece, this like scope of objectives. Now, there are other agents that dealt with different things like partners or sponsorship or whatever. But that is still very well defined as a part of the process. So it does get a little more complex, but it is still very doable. So hopefully that answers your question. I'm always happy to take a follow-up if you've got additional questions there. Okay, context. This is the data side. So when we're looking at different data sources, we need to understand, where is it coming from? What does it mean? Is it trustworthy? And what we typically do here is we do connect to data catalogs, because they provide a lot of metadata and context about data. Not just definitions, which are super important, but when we look at lineage tools, we can actually see what the source systems are. And you can get more context from the source systems as well. So think about it this way. If we're connecting with a CRM or like a Salesforce, for example, we're pulling data from there for whatever use case we have. Knowing that it's coming from Salesforce is really important. So, okay, it's coming from a CRM. Knowing what the field is and the field definition is super important. Knowing if it was like a user-defined field, or if there was something that, from a best practice perspective in a CRM you have, for example, pipeline stages, right? Those stages are pretty well defined for people in sales teams for the most part. You can change them or rename them or, alter them a little bit, but typically it's like discovery, value proposition, goes into like meeting with stakeholders, decisioning, verbal commits, and then, towards the end, right? But everybody kind of tweaks it and defines it a little bit differently. We can grab context about that general process and framework, as well as the different fields and what they mean and how they're defined. And the fact that it's coming from Salesforce is important. But additionally, it will have things like, user like acceptable use policies, or like sensitive, PII tags, or things like that, where we have data sets that we are leveraging, where we know we have PII in them because they're tagged accordingly and have been curated inside of catalog. And we can see if they're like certified or not certified, who owns them, which is also really important. And those things are critical because those have implications on risk, and they have implications on what we do with the data and how we process the data. For example, we may want to leverage synthetic data upfront because maybe it's highly sensitive, or we may have to go through a redaction process where we redact information before feeding it into a system. We saw a real use case of this in legal with legal contracts. They were not willing to send all of the information inside of the legal contracts to the AI system. They redacted a bunch of information prior to sending it, and then allowed that vendor to see that data set. So there's a lot of information in here, right, about the data that the system is leveraging. And AI systems are nothing without the data. I'm sure everybody hears that all the time, but it's true. And so how do we connect all of that metadata and context into the system? And then once we have that, we know if there's an issue or not, right? We might be blocked with the CRM records because of an acceptable use violation. Like, we got that information through a marketing like initiative or something, and maybe there's some regulation around what we can use it for. We can use it for internal operations, but we don't have permission to use it for this AI system, for example. So we might have a constraint check there. And you'll see the quality signal there too, right? There are lots of tools out there that do quality assessments that are really, really fascinating. In fact, I just got a really cool demo of Anomalo and some of the stuff that they're doing on data observability and data quality evaluations, and what they can set up by default for every data set, and what you can do custom for each data set as well on assessing data quality. Then you can connect that to a catalog, and you can get a general health score of data sets. You can pass that through as even a feasibility blocker or not. So this is what I mean by the highly connected ecosystem for this blueprint. It is not just a page in a SharePoint site. You cannot operate that way. It becomes stale very quickly. Nobody knows where it is. Nobody works off of it. Nobody pulls from it. So you need something more dynamic. Then we go into reasoning. And this one is hard. So I'm not going to sit here and pretend like this is easy. Now, for things like this example we're using, we can get pretty good reasoning as to why. In fact, you are obligated to, from a regulatory perspective, to provide a reason. If you deny somebody a loan, for Fair Credit Act, right? If you deny somebody a loan, you have to give them a reason if they request it. And that is to really ensure that people are not being discriminated against. And so from a reasoning perspective, we have to use a method in which we can prove why they were denied. And so we can look at all sorts of features for this, your debt to income ratio, your payment history, your credit utilization, your employment tenure, right? These are different features that we've leveraged in the system. And so we can kind of tie it back to that. And so not everything is so self-explanatory. Where this, we can actually just look at stats and look at the weights of everything. And we can trace it back to different features inside of the model that pushed us towards this result. But as we get into the less explainable types of methods, like neural networks and a lot of generative tools, and sometimes agentic, if you're not implementing traceability in the right way, this can be a lot harder. And sometimes it's not even totally necessary if that's not important to you, but explainability is typically a really big piece, especially if you're going to try to understand how it got to what it got to, and how you want to troubleshoot that. So super important that we at least attempt to provide some reasoning behind this. Plus, as I mentioned earlier, this actually provides a lot of trust in the system by the end users. So when the end users can see why it's making its decision, we tend to feel much better about it. Finally, boundaries. I talked a decent amount about this, but if we don't have our set of constraints somewhere that we can reference, then we're going to have no consistency on how we're evaluating risk. And if it's not comprehensive, we're going to miss a lot. So again, from my talk yesterday about scaling AI governance, especially in an agentic world with guardrails, we need to be talking about a holistic view of risk. And especially in regulated industries, we tend to get really hung up, obviously, on like the regulatory side, which is important. But as most people know, a lot of advanced organizations are much further past the regulators. And so they're a little bit stuck because they're trying to figure out how to appease regulators in this environment right now. And I think, again, it boils down to those different dimensions of risk, which I've called out before, which is like financial risk, operational risk, reputational risk, harm, like physical harm. In some cases, if you're working in manufacturing or autonomous vehicles, anytime that there's an error, or even healthcare, right? Of course, physical risk is this huge, huge issue there. Reputational risk is another big one. Sometimes you really can't undo a reputational risk there. So it depends on the industry that you're in and what exactly happened, but reputational harm is a huge issue. We've all seen the headlines, right? So the boundaries we're talking about here are not just like, hey, you can't have root access to this system, but so not even just from the security side, right? What can it have access to? What can it do? What can it action on? But also the regulatory, the legal, and we all have, most organizations by now have an AI governance committee, which is multidisciplinary and has several different functions inside of that. I usually don't see communications folks involved, quite honestly, on that reputational harm side. But they do try to create a multidisciplinary approach to this, which is correct. But it needs to be rooted in principles that are applied universally, and it also needs to be context specific. So this is why we end up in never-ending committee meetings about risk, because you'll get a lot of it depends, right? And so you get on a call and all of those individuals will discuss it. And so if we step back and think like, why are we getting on a call to discuss this? It's because there's context that's missing that somebody has in their head that they need to explain, and they need to understand more context about the system, its intention, who's using it, where, right? All of this stuff. We end up getting on meetings so that we can gather that context so that we can make the call around a risk profile. And a lot of that stuff can really be codified somewhere. I talked about policy as code yesterday, which I know is resonating with a lot of people because they're trying to get to a more automated way of evaluating risk. And it just boils down to being able to capture the right context and have the right policies that are stored and ways to execute on those. So the boundary side is, in this example, pretty straightforward, right? And we'll talk about some of those boundaries here in a second. But there's a lot to it. And there's a lot of ways that you can actually make tangible decisions. And so I always split them into two. There's the universal principles, there's the universal boundaries that you have on all AI systems at your organization. And then you've got context-specific boundaries, depending on how it's being used. I had another example that I mentioned yesterday, which was meeting note transcriptions, right? Maybe some of you wouldn't be surprised, but some of you might be surprised to understand that this was a huge hangup for a lot of companies to turn on AI note takers and like meeting notes, especially just in Teams in general, even though it was a trusted vendor and they were all using Teams anyway, because legal in some cases were really hung up on the fact all these transcriptions were being stored and persisted and can be used as discovery. So that made them very nervous. Like if they were to enter into discovery, they would have to disclose all of these records of everything that was said on all of these meetings, again, without context of what actually was happening in the meeting. And so if you're meeting about some random project, doing project management and getting status updates, that's one use case of a meeting transcription. And maybe you're feeding that into your project management tool. If you're in the board and you're talking about financials, it's a little bit different. So there's context that matters on how it's being used at the use case level. And it's not just at the technology level. We can't just look at it, blanket, and approve or not approve. And so when we're talking about risk dimensions, we're looking at regulatory constraints and dimensions. So if we just focus on the regulatory side, there's lots of different areas throughout this quote blueprint where this applies. So again, data must be accurate, right? The FCRA, there are some regulations around that where we actually have to have proof about the data that we have and the reason codes being stored per applicant. So we can see the source is documented. So we've got all of that. The Bureau pulled timestamps, consent logged, refresh cadence on file, right? These are all things, green light, good to go. Feature staleness, 47 days. Income feature outside a 30-day freshness policy. Decision based on stale data. So we need to get the most up-to-date data. Can't have stale data. Reason codes not stored per applicant. Big problem. We have to have that. So we need to be able to persist that somewhere. Again, super simple examples, but the idea is to give you the outline, the framework, the process, so you can apply this. Decisions must be fair. This is pretty straightforward too, right? We have different segments of different people of those applicants in protected classes, which I think the ones stated are like age, gender, things like that, race. And so we're looking at different segments of protected populations. We want to understand if there is a, discrepancy between those segments. In this case, 2.3x on segment D applicants that are wrongly denied more often than segment A applicants by the same model. Big problem. We need to provide an equal opportunity for credit. And so we need to be able to surface this. So this is a constraint from a risk perspective. Like if we are performing where we don't have any of these issues, then we're compliant and there's not an issue. And the second we deviate, we're not. So that's a boundary. And that boundary needs to happen at the design level because when we go to deploy this, we have to have observability that's monitoring that. It's a spec. It's a requirement. So that happens at the design level because we know that we're touching that data. We know the decisions that we're making, which is around lending. And so we have to have that. And again, this is just a really simple example, but you're seeing how I'm tying all of these things together. We typically see this as just like a risk checkpoint. And that's not what we should be doing. We should be pulling it up in the process at the design level. And we should be able to kind of identify that like automatically. Like your data scientists and your data folks, they probably know this one, but there's, if you're in financial services, you're probably aware of this. But if it's different, if it's a different type of risk constraint, you may not be aware of it. And so we need to have certain triggers for that, where it's like, hey, if a decision is being made about lending, trigger this risk constraint. Automatically, right? We should be able to pull from a repository. We should be able to assess the decision points to be able to surface that constraint on a risk perspective. So we're like, oh, hey, we have to design the system for this, right? Same thing with data. We're pulling PII. Oh, automatic trigger. Like here is an implication of that from a risk perspective. Decisions must be explainable. They have to be explainable. As I mentioned earlier, right? Requires lenders to explain the specific decision to a specific person. And so we can use different methods like SHAP that can show exactly which features push the model towards denial and by how much. So we can look at, annual income, employment tenure, things like that, right? So push towards denial, debt to income ratio, obviously, right? And then we can always use that as a category that we can give back to that end user if they ask. All right. So same system. We're still doing the same types of activities. We're still having the data engineering team process data, get data ready, give it to you. catalog data, right? We still have the AI engineers building the systems, developing the systems, building in observability and monitoring. We still have risk teams doing evaluations and ensuring that those risk scores are correct and that things are okay to go live. We still have business teams who have to adopt them and have a lot of input on how that system that's being built will impact them on an operational level. It's the same system. We're just suggesting that it's intentionally designed because all of these things inevitably have to happen. It's just that there's a lot of inefficiency happening today and things that get stuck or never move forward because they can't get resolved. And if we just follow this from a framework perspective and we capture all of this information again in a live, highly connected ecosystem that several people can point to and can interact with, this moves so much faster. So at the top of this webinar, I have mentioned the lifecycle part. We're talking about objectives of an AI program. We want to place the right bets. We want to see ROI. We want to get a good outcome from what we're investing in when it comes to AI. And then we want to manage risk. We want to make sure that we're not doing this irresponsibly. And those two things tend to be the objectives, like speed and risk. Speed and risk. How are we managing, speed, value, risk, right? And that's true. And so I'm actually suggesting this as an approach to address all of those things. So if we have all of that information, then speed happens, trust me, much faster. We've seen, in some cases, 10x faster when you have a system like this implemented. Risk actually is a lot more robust, and it becomes less of an argument about what's risky and what's not, and more of a verification process. So it's less of, is this risky or not? And it's more of, okay, I've verified that, and now I'm part of the mitigation process, which I actually think is a really interesting paradigm shift for risk teams because they're so used to just being like a gatekeeper or a yes, no. Like, hey, this is risky, no. Because they're doing the evals themselves, which I'm not suggesting we pull them out of evals by any means, but I am suggesting that we automate a lot of the things that are pretty redundant, and we enable them to think more critically about risk and how we approach risk from a holistic lens, and we involve them in the mitigation process. So it's not just no, but like, here are the ways that we can actually mitigate risk or de-risk this use case. So we can move it forward and we can say yes. And trust me, I've seen the whole spectrum. I just talked to somebody yesterday who is part of their AI committee, very, very, very large company. She's like, we've never said no to anything. Now they are regulated, but they're not in banking or financial services. But, they said, we've never said no to anything. So like things just go through. And so they're more just like, I guess, cataloging it and checking it. Whereas I've worked with some other organizations who are in financial services where they don't approve anything. So I've seen both sides of the spectrum. And that's why I think, like, from the risk lens, as we're talking about this, right? Speed, talked about risk, we're talking about right now, and then value. We can actually get to more of a comprehensive value understanding if we can capture more of this information up front. And it can be more dynamic, right? Because we have more of an understanding of the system and its impact on operations. So that's the suggestion, is same system, same process. We're just being a lot more intentional and methodical about how we're doing it. And understanding that, AI success is system alignment. It's not just model performance. And I think everybody knows that. I really, truly think that this is the crux of the problem today for people, and why stuff isn't moving faster. It's just this massive miscommunication and massive inefficiency of communicating between all of these different teams to try to get to the right answer and get something to go live and get it adopted and used. It becomes a huge challenge. So I do see there's another question that came in, but thank you for sticking around for 50 minutes and listening to this. Hopefully it resonates with you. We've got another article coming out on this topic here shortly, so stay tuned for that. But yeah, another question that came in. Okay, who owns the blueprint after launch and how do you prevent it from becoming shelfware 6 months into production? Yeah, good question. This is the main thing I've been advocating for. So who owns it? You really do need an AI program owner. We talked a lot about this. Almost every company is structured a bit differently. The types of teams we see are, an AI COE, and there's a lead of that COE. And they kind of own the quote operating model of like who does what, when, and where. And then sometimes they also own the use case repository and like the inventory of AI systems. And they typically work pretty closely with like a transformation office or change management office that helps with delivery and implementation. They obviously work with an AI governance council, which may or may not sit under them. I've actually seen some companies that their whole COE is the governance council and it has none of these other parts to it. And then we also see sometimes liaison or advocate networks, which are like anywhere from like 10 to 60 to 60 plus people who are embedded advocates for AI across the organization who work as a liaison. And then, we see the platform teams. So platform teams being your data scientists, your AI engineers, people actually building, and then you have your data teams. And so there's a lot of teams, there's a lot of coordination. And so we usually see kind of the program owner own all of that and is accountable for that. They're also accountable for the program outcomes. They typically have a program manager underneath them, and they would be kind of responsible for ensuring that these blueprints don't become stale, right? They own those blueprints. Think about from a organizational structure lens, they like when you're thinking about like a data catalog and who owns the freshness of data catalog, you have typically an owner of that whole system. Same thing with this. You would have that program owner own those blueprints and ensuring that that blueprint is connected. And so obviously that's what we do. That's what our platform does is we help you integrate with the entire ecosystem so we can help keep that up to date and fresh for you. We've seen some teams try to build this on their own. The problem that we've seen with people doing that, obviously, is that they just can't build it in a way that's dynamic enough to keep it fresh over time. If we're going to require manual intervention to keep this thing fresh, it's not going to happen. It's the same thing that we see with data stewards and data quality and data catalogs. We can't rely on people to go into a SharePoint site and make updates to something. We just can't. And so we need to be able to capture this information. Yes, some of it's still going to be manual to an extent, right? But there's a lot of ways to automate it. And there's a lot of ways through integrations and through leveraging AI actually to pull that context in, ensure that it's accurate, and then connect it to the whole ecosystem. And so I think that's how we keep it from getting stale. And then from an ownership perspective, we have pretty strong opinions on things that we've seen work well. That structure I just gave you is pretty comprehensive of most mature organizations. And then the other point I'll note here is that typically what happens is that they all centralize first. And so everything kind of goes through a centralized team. And obviously that can be quote slow. But you can get to a federated model where it's almost like a franchise model where you have the centralized team with standards and like the centralized kind of inventory and blueprint system. And, everybody has access to it. And then you can start to set up embedded systems like this that kind of connect back through this system where it's like, oh, I don't have to go through this committee meeting. I can actually just interface with the centralized blueprint system and I can put my requests in there and then we can make sure that it's all connected and we can pull the context in and we can just, do risk evaluations automatically. And trust me, it's possible. We've done it. So it's, you just have to connect everything. You have to be thoughtful about how you're capturing that context and how you're doing a closed loop process too. Like you can't just ship something to production and then have no monitoring or observability that's actually checking against the original blueprint. Think of it as like an inspection of a home. Like we build a home, here are the specs, here's blueprint, send an inspector in and take a look at everything and make sure that it's up to speed on all of that. So yeah, hopefully that helps. Another question here. We have 5 minutes left, so hopefully I can get to them. Do you have suggestions for how to convince leadership or the business side that an AI blueprint is needed when they're so comfortable operating in a certain way for so long? Yeah. Like I said, I would make this as hands-off as possible for them. Like if you are, so two thoughts here. Number one, you can send, well, actually three. You can send this webinar recording to your leadership and see if it resonates with them. I'm sure they want things to move faster and they want higher value. So I can assure you that that's true. And there's proof in leveraging this methodology to do that. So that's one thing, is just like an education. The second here is that, like I said, the blueprint, if you're making it some centralized like document that you're forcing people to go into and find and add stuff to, you're not going to get adoption. You're not going to get them to do that. Here's an example of what I mean by automated. So if, let's say that they submit something, like an idea, and everybody's got like this idea submission portal, right, somewhere. Some people are using ServiceNow, some people are using Microsoft like Forms or whatever the capture mechanism that you're using is totally fine. That idea gets submitted, super vague, doesn't have a lot of details, missing tons of information. In fact, we calculate a completeness score, and typically it's pretty low in terms of what people put in to start, which is okay. Like they don't know the answers to all those questions. And it's unreasonable to expect them to. And so we have something that we built called a refinement assistant that will actually dynamically ask strategic questions back to them, try to pull as much information out of it as possible. And then we know what a complete, submission would look like. So all the information that we need to capture and where to go get it. Some teams may get on a call with them. They may say, this is a really interesting idea. Let's get on a call with them. Let's put a business analyst or a product manager on here, and let's ask them more questions about what they're trying to do, right? We can transcribe that meeting, then we can feed that into the system. People are willing to get on a meeting to talk about their idea. So think about incentives. Think about how you can capture it. We talk about it as a capture problem, capture and collect, that context. There's several ways to do it. Something more engaging, like a chat experience, or like literally a virtual meeting, or just knowing who knows what in a system and what's reasonable. Like sometimes, there's a lot of people that really don't know what PII is who are in your business and who are going to be like, I don't know what that is. And I don't even know if that's applicable to what I'm talking about. Like, I'm not thinking about it in terms of data sets and personally identifiable information. So there's a lot there, like, to think about how we can actually convince people to participate in that. And if you do a blueprint right, and you can even hook up AI on top of it, people can query it and ask it questions and add more context and do what I call like reconciliation of information too. Like, do we have conflicting information anywhere that we need to reconcile, and who do we pull in to reconcile that? And I do think once people see how powerful that is, they actually want to be more involved there. So there are a lot of ways to approach that. Last question, and then we unfortunately have to conclude, but these are some good questions, so thank you. What's the practical forcing function that can get risk and legal into the room at blueprint time before engineers have already built something? Yes, this. Right, the practical forcing function here, again, is including risk in design. So the way that we've seen this implemented is that there's actually several risk checkpoints along the life cycle. It's not just idea, refinement, technical feasibility, proof of concept, pilot, risk gate, approval, go to prod. Actually, what we've seen is that there's idea, some refinement, risk evals. Even though it's fairly incomplete, we can surface the things that are incomplete and we can run initial risk evals on them. Again, if it's automated, you can actually just do that automatically. And then it goes through an initial checkpoint. Like, this is a high risk idea. Here's why. Here's how you can mitigate it. We could actually send it back very quickly back to the submitter and say, your idea is a little high risk. Here's why. You want to make any adjustments on that? And they could say, no, it's worth it. It's worth the value risk trade-off is worth it. Keep moving, right? Then we can go into feasibility. So there's actually risk checkpoints along the way. The reason most people don't do this is because the risk team is typically way over capacity. And so they just don't have time. And so the more you can automate some of it, the better. So hopefully this was helpful. We recorded this. I know we're live right now. I think you can see it again on LinkedIn pretty easily, and we'll post that. And then we'll also post a recording on our YouTube channel, so you can send the YouTube link around as well. And I really appreciate everybody's time today. I know this is an hour of your day, so thank you for trusting me that it would be valuable. Hopefully it was. And we'll have a lot more good content for you coming up soon. So thanks again, everyone, and we'll see you at the next one.